All right, C495. Just wanna make sure everybody's on the same page. So we are working on the lateral system at this point. So I assume every team should completed their floor framing design. So I'm gonna repeat this. I'm gonna create this video. Probably I'm gonna create the video one step at a time. But hopefully you guys can watch it and complete it, your lateral system study, and bring all your updated model uh, next week. Okay. So, all right. So this is what you have. First floor. I'm gonna run it and just check current model. See, this model is has all composite beam design is complete. I want to just run check composite beam design. Okay, I'm gonna check the plan. So need text. I'm gonna graphic preference and make this 7 or 8, so make a bit more visible. Still, maybe some grabbing modes. Okay, yeah, okay. So this example, I have a typical 18 by 40, number of stud 53, camber 1.25. Wow, what did I use for design load? So uncheck. Okay, since I'm using Lateral 100, that's why. Okay, okay, assume this is okay and complete, right? So, okay, there are a few things you can do it. I think first of all, is today we just everybody already copy entire wall or building all the way up to the 40 story without modifying the wall, right? The wall layout. We actually segmented, basically cut the wall piece by piece by 3 by 1, and you could do that too. But I typically better workflow. I think I'm gonna just modify at the first typical floor and then copy 40's 40's time. So what I'm gonna do, this is I'm gonna put your floor, yeah, the floor model, right? I'm gonna name it this 40 story floor model, right? So this is a typical floor model. Now I'm gonna save as another file, not floor. This is lateral model. So this is lateral model of the number 1. And then, so what I'm gonna do, put it on the plan. I'm gonna modify the wall, right? So at this point, so what we need to do is we need to do all multiple practice. First of all, we're gonna segment it so that we need to kind of cut this wall, and we're gonna add the wall opening and for the entrance. So these cases we just select, these cases I have already segmented. Let me see in the plan. No, this is one entire wall, right? So if you already, if initially you draw the wall, entire wall, I think this morning I show you, you could, I'm gonna turn up the floor. I'm gonna turn up the floor. Okay. And then I'm gonna select this. Oh boy. I have to turn up the opening too. There is an opening object there. Right. So I'm selecting. I'm gonna cut this. Select. So what you can see, you see the number of 4 shells selected. Go to edit. I'm gonna go to edit shells and divide the shell, which is I'm gonna divide this one big pieces into 3 by 1. See, right? Basically this is meshing. So I'm gonna open this. So assume this is corridor wall opening, right? And second one for this, for example, I'm gonna mesh it this one as well. go to shell and divide 3 by 1. So I'm gonna mesh and cut it this, and then I'm gonna add a concrete link beam to tie this wall between the wall. So these cases, I'm gonna put it on the plan. I'm gonna save it since I'm gradually progress. I always save my latest file. So what I described this morning, we need to create multiple concrete strengths, right? Since this is a 40-story building, eventually we're gonna use various concrete strengths. I mentioned it, we can use various high-strength concrete. When you open this ETABS default, probably you only have a 4,000 psi concrete. So maybe I'm gonna start with delete it. I cannot delete it. It's just okay. 4,000 and 4,000 and 5,000 is already available, but I'm gonna create multiple more concrete strengths. Since this 4,000 concrete strengths has a weight density, but I think Young modulus is the one we need to update based upon the concrete strengths. You know, in order to, before I create a few more, I'm more kind of convenient. Familiar with the Kips inches as a Young modulus. I change the unit, go back to material. So I'm gonna use the 4,000. I'm gonna copy, make 6,000 psi concrete, right? I explained that there is a built-up calculator here. So this is a function of square root of f prime c. So 6 divided by 5. So I'm gonna make another Young modulus for 6,000. Today I show you this formula basically, right? You could calculate it, you can type in this, but this is a KSI, right? Young modulus, normal weight concrete Young modulus, you can calculate 57 times square root f prime c, right? So it varies among the concrete strength. So I create a 6,000 here. I'm gonna create a few more, 7,000. Now here, square root f prime c. Since I copy the 6,000, I'm gonna scale up by using square root f prime c, the ratio 7/6. So this is for 7,000. I'm gonna create another time more, true, 8,000. So square root 8 divided by 7, right? And one more, 9,000. So how many concrete strengths is typically I use? Depends on, but I think not that many. This is 9 divided by 8. Probably I'm gonna stay with 3 discrete concrete strengths for the wall and column. So I'm gonna use wall with concrete strengths between 7, 8, 9, or 9, 7, 5, something like that. It's more engineering judgment. All right. So I define this material properties, and then I'm gonna create a few more wall section properties that is just associated with the concrete strengths. I have this model I already created. See the W24 24-inch wall for concrete strengths. I'm gonna use 9,000. I'm gonna use a gray color. So this one I'll usually prefer to kind of using some prefix so that 24-inch wall, concrete strength, cylinder concrete strength 9, right? So I'm going to use it. Same thing. I'm going to copy. This time, maybe 20, C8, C8. Okay, change to 20. Okay, create another 18, C7, 7,000, 18, right? So this is section properties with their concrete strength. So I already defined, save it, the section properties. So the bottom floor. So first of all, bottom floor, I think I'm gonna assign shell wall sections as the starting 24 inches thick and concrete strength 9,000 as a base, the concrete wall thickness and strength. All right, the second one, as I mentioned before, we're gonna use concrete beam because this is part of concrete. The beam is part of concrete wall construction, so we always use the concrete beam with the concrete wall together. So in order to do that, I'm gonna create few uh, the link beam concrete beam by clicking here, add a new property, right? This case is I'll call it our link beam, link beam, right? The width is matching usually wall thickness, so 24 inches. The depth it varies, but I'll keep it with a 24 inch deep. But concrete strength for the wall, 24-inch wall, I choose 9,000, so I'm gonna match the concrete strength as well. When they pour the concrete wall, they're gonna pour the link beam as well. So we always match the concrete strength, right? So 24, 24, C9, C9. Okay. All right. So this is the one I'm gonna copy. Link beam now 20. So now next wall thickness is 20. I keep the same depth. C8 this time. Depth is remain. Width I change to 20. So 20 by 24. This case is concrete strength 8,000. So I'm gonna copy one more time. LB, right? Now 18 by 24 is 7, right? Oops, is 7. So this is 18 and concrete strength 7,000. Obviously this is an example, but I think this is the work floor, so I want you to pay attention to the work floor. But it's in this order, maybe it can be, it's totally engineers your based upon your practice, but you have to define the section properties. I said it. So now what I'm gonna do, I'm gonna draw the link beam, coupling beam. So click the beam. I'm gonna choose link beam L. Yeah, link beam. But see that wall thickness 24. I'm gonna click the 24 by 24. I'm gonna add this wall. But make sure this is concrete construction. They are monolithic pour, so this is should be continuous member, no moment release, right? So I'm gonna draw this. Oh, you see, sometimes you miss the point, so you have to redraw it. Snap. Okay, using snap tool better. Make sure you click the nodes. All right. Click, click, right click, and move on. Click, left click, right click. All right. So I drew all the link beam. So let me check the section name here. So see, the link beam is 24 by 24 C9, right? So I draw the link beam. So if you want to look at the extrusion, you could either click this extrusion. Oh, this is not extrusion, and this is the one. Okay, see the link beam, the concrete beam, right? If you want to turn on the wall shell as well, so this is extrusion of the wall. We're using 24-inch wide too. Graphically looks fine, right? So okay, I'm gonna turn off the extrusion. Okay, I'm gonna stop here.